Today we're learning about complex fractions. So complex fractions are when you have a rational expression that has at least one fraction in its numerator or denominator or both. So if I scroll down and look at an example of a complex fraction, you can see here that the numerator is two fractions and the denominator is a fraction plus a whole number. This in its entirety is called a complex fraction. It's when you have a lot of stuff happening in both locations for the numerator and the denominator. But simplifying them is pretty simple, especially since we've already learned how to add, subtract, multiply, and divide. So step one to simplifying is to create one single fraction in the numerator. And to do this, you're going to be required to add or subtract. Then you create one single fraction in the denominator. After you have one single fraction in both the top and bottom, you need to rewrite using the division symbol. And then you follow the normal rules for dividing, which means you flip the second fraction and you multiply by the reciprocal, which is what we've been doing for a few classes now. And lastly, you simplify if you need to. So if we look at example 1, we have 1 over x plus x over y, which we can combine so we can add these two expressions together. We're going to have to multiply the first expression, 1 over x, by y times y, which is the denominator of the second fraction. And for the second fraction, we need to multiply x over y by x over x, the denominator of the first fraction. This gives us y over xy plus x squared over xy. And when we add our numerators together, we have y plus x squared divided by x times y. This here is going to be our simplified numerator. Next, we have to repeat the process with our denominator. And our denominator has a fraction plus a whole number. So we currently have 1 over y plus 1, which is 1 over 1, and I'm going to write that because we're adding fractions. The second expression has to be multiplied by y over y, which gives us 1 over y plus y over y. And that simplifies to 1 plus y divided by y. Now that we have simplified both our numerator and our denominator, I'm going to rewrite my complex fraction. My new numerator is going to be y plus x squared divided by x times y. And this is over, or divided by, our new denominator, which is 1 plus y divided by y. So at this point, we are going to take what we currently see as our fraction bar or our division sign, and we're just going to rewrite this as a division problem with a typical division symbol. So I'm going to write this as y plus x squared divided by x times y. And I'm using my division symbol. We're dividing 1 plus y over y. So I changed where I currently had a fraction, and I just moved it to a division symbol. But now I can multiply by the reciprocal. So now I can flip this second fraction, and I can multiply. That's going to give me the expression of y plus x squared divided by x times y. And I'm multiplying this by y over 1 plus y. Now is when you can simplify anything that is common between the numerators and the denominators. And the only thing that's common is the single value of y. So I'm going to leave my final answer in factored form. I don't think there's any reason to expand this. I'm going to write this as 1 plus x squared. That's all I have left in my numerator. As for my denominator, I have left x times 1 plus y. X here and 1 plus y here. So my final answer is x multiplied by 1 plus y in the denominator, and this is your simplified complex fraction. As for example 2, for number 2, we have a numerator of x plus 6 divided by x, and we are subtracting 1 divided by x plus 2. For a denominator, we have x plus 2. No, we have x squared plus 4x plus 3 divided by x squared plus 2x. So I'm going to start by simplifying my numerator, and by simplifying I mean creating one single fraction. X plus 6 divided by x is going to have to be multiplied by the denominator of the second fraction. So I'm going to multiply the top and bottom of this by x plus 2. The second expression, 1 over x plus 2, is going to have to be multiplied by the denominator of the first fraction, which is just x. So as I simplify these, I need to make sure I distribute all my terms in the first set, or the first numerator. And when I do that, I have x squared plus 2x, and then plus 6x plus 12, divided by our common denominator of x times x plus 2. My second fraction, when I multiply them together in the numerator, I'm left with just x and the common denominator of x times x plus 2. Now I can add my numerators, but when I add my numerators together, you just have to be careful of that subtraction sign because, of course, you are going to have to subtract everything in the second set of parentheses. In this case, it's just one single term, so not so challenging, but previous problems have been a little bit more challenging. So when I add or subtract all of my terms together in the numerator, I'm left with x squared. I have 2x plus 6x, which is 8x, and then minus x, which is 7x, plus 12, divided by x times x plus 2. And this here is my simplified numerator. If I look at my denominator, this is already one single fraction, so I don't have to do anything to that, which means I can go right to rewriting my two expressions. My numerator is x squared plus 7x plus 12 divided by x times x plus 2. And my denominator remains the same as what it started as, x squared plus 4x plus 3 divided by x squared plus 2x. And now, just like the last problem, we're going to eliminate this division bar, and we're going to convert this to a division symbol, giving us x squared plus 7x plus 12 divided by x times x plus 2. And now we are going to be dividing by x squared plus 4x plus 3 divided by x squared plus 2x. Now in the next step, I'm going to flip the second fraction and I'm going to multiply. But within this step, I'm also going to factor. So anything that I can factor, I need to go ahead and do that. So any numerator or any denominator. My first numerator can factor out to x plus 4 times x plus 7. I'm sorry, x plus 3. X plus 4 times x plus 3 divided by x times x plus 2. My second fraction is going to flip. So my numerator is now x squared plus 2x, but that has a factor of x, and we can take that out, leaving us with x plus 2. And the denominator of that, which is originally the numerator, is going to factor to x plus 1 times x plus 3. And at this point in the complex fraction, we can eliminate the value of x. We can eliminate x plus 2. We can eliminate x plus 3. And our final complex fraction simplifies to x plus 4 divided by x plus 1. And that's your final answer for number 2. So please follow along as I go through the on your own section. I'm not going to be talking through my answer, but you can watch as I work through it.